Hi everyone. I wanted to start today by just going over yesterday's homework on percentages. So this would be a great time for you to pause the video and really go through all the examples and make sure if your answers are correct or incorrect. I will then take some time specifically to talk about the three examples, 1, 2, and 3 that fall under example 4. Because those were definitely the three most challenging questions. So if you would just pause the video right now, check through examples 1 through 4, and then we'll go over the three examples from example 4 specifically. All right, let's start with example 4, number 1. It says Alan is selling his car at an auction. He must pay $500 to the auctioneer plus 5.5% of the final selling price of the car. After selling the car, Alan paid the auctioneer $720. What was the final selling price of the car? So in this instance, Alan is getting an audience for his vehicle. Because he's getting that audience, he has to pay the people that are hosting the auction some of the money, and then that's how they operate their business. So let's start by defining a variable here. We know that, let's see here. Sorry, let's use a pen. We know that our unknown is the price of the car. So let's go ahead and use X for the price of the car. And then we also know that he had to pay two different things to the auctioneer. He had to pay $500 just for having his car there. So we'll call that the fee that he owed them. Plus, he had to pay 5.5% of the selling price. So we'll say plus 5.5% of selling price. And then that all was equal to the total that he owed the auctioneer. So let's set it up based on the information that we know. Fill in the numbers for each of those pieces. So starting with the fee, we know that fee, and you don't have to set it up like I set it up exactly, but this is a general setup that we could use here. So the fee we know is $500. We need to, since this is an equation, write the 5.5% as its decimal form. So that means 5.5 out of 100, so 0.055 x, because it's of the selling price, so times the selling price, and then the total that he owed them came right from the problem, $720. Now we just need to solve it. So we'll start by getting rid of anything not attached to our variable using inverse operations. So we'll subtract $500 on both sides. Then we end up getting an answer of 220 on the right. Next, we'll divide by 0.055 on both sides. And when we do, we find that the cost of the car should have been $4,000. So make sure that you got that one, and especially that you understand the work that went along with it. And then we'll move on to example 2. All right. All right, so on this next one, it says Jaden is taking a true-false test. He guesses 12 true and false the rest of the time. He got 75% of the questions correct. The number of questions he got correct was 15. Write an algebraic equation to find that can be used to find the number of times Jaden guessed false. Use X to represent that number of times. So we know how many times he guessed true. We don't know how many times he guessed false. Now, I would not recommend taking a true or false test and completely guessing, but that's what he did in this case. So let's go ahead and read the statement here that we need to use the most, which is Jaden got 75% of the questions correct. So what we'll do to set it up is we'll take that statement if we know that that equals the amount that he got correct. So we'll take the 75% as a decimal form. So let's just write it down right here. 75% of the questions correct. Here's the problem. We don't know how many questions there were. So we'll do 0.75 of means times. The only thing we know about the questions is that they were all true or false. So we know that he guessed 12 times true and x times false. So I'm going to actually use the little expression in parentheses there for the sum, 12 plus x, to show the number of true guesses plus the number of false guesses. Then that whole sum gets multiplied by 0.75, and that's going to be equal to the amount that he got correct, which was 15. So I'm going to put 15 right here. So the next thing that I need to do is see which of the equations from up above matches my answer. And I can see right away that A is the same as what we came up with. All right, the next one, question 3. This one, we will set it up very similar to the Steph Curry problem from yesterday. So it says to make the Steelers team, the new kicker has to make 90% of his field goal attempts at the tryout. The first person trying out has currently made 14 field goals and missed 2. How many of the 24 remaining field goals must he make to become the Steelers' new kicker? So again, there's like a key statement here, but there's really 3 parts that we need to follow. The first thing that I have to know is how many attempts that this new kicker gets. So we can gather that information from the problem. First, I know that right now he has made 14, so there's 14 made, plus I know that he has missed 2, plus I know it says that he has 24 remaining. Remaining. So when I total all of those up, that tells me that he ends up getting 40 total attempts. For step number 2, I need to figure out how many he needs to get. So it tells me that that's 90% of his attempts. So the amount needed is going to be 90% of the 40 attempts. So 90% as a decimal is 0.9. Of means multiply. 40. And then 0.9 times 40 would give us 36 needed. That is not, however, what the question asked. The third and final step is to figure out how many of those 24 remaining that he needs to get in order to be the new kicker, considering he's partway through his tryout. So how many more? We would take the 36 that he needs minus the 14 that he already made, and that would tell us that he needs to get 22 more field goals to be named the new kicker. Of the 24 remaining, he could have missed 2 if that's what the question had asked. All right, we're going to move on to today's lesson. And today's lesson is very similar to the previous 2, except for now we're going to be focusing on estimating with percents. This is something that adults do pretty much very routinely. It's a very helpful skill, and it will help you to evaluate if your answers are correct or not. The target is just simply I can estimate with percents. As a warm-up, we reviewed that example 4 from the homework. So many money situations involve finding a percent of a number, and it's not always money. You'll find that there are others as well, even like if you get a quiz score back and you just want to roughly know what your percentage is if you don't have a calculator handy. Often with those money situations, however, we want to be able to think about our answers in our head. So you don't want to have to always get an exact answer, especially when it's giving a tip or something along those lines, estimation is a great tool to just come up with an answer that's close. So what I want you to think about is when we're doing these problems, you should be able to do it without a calculator. So let's write that in this little box. Should be able to do it in your head. Now that said, you will have a calculator for these problems, so it's kind of misleading, but the point is you shouldn't need the calculator to do it. If you're doing it exactly like 8.1 through 8.3, then you're doing it incorrectly. This is a different skill. Estimating is its own skill. It's something that's valuable. It will be valuable to you in your future, so we want you to know how to do it, but we also don't want you to rely on the calculator, because then that'll take the estimation process away. So we're going to give you a few tools that you can use for estimating. The first one is compatible numbers. So compatible, you've probably heard that word before, right? If two things are compatible, they go well together, they fit well together. So here's an example of two sets of numbers that do not go well together. Compatible numbers are typically used if you had two numbers and you were trying to approximate the percentage that one is of the other. So for example, 9 out of 13, that is not very compatible, right? Those numbers don't go great with one another. But if we wanted to try to get numbers that go a little bit better, we could say, okay, well, 9 out of 13 is somewhat close to 9 out of 12. And I know that 9 out of 12 simplifies to 3/4. And 3/4 is a very common fraction. We'll talk about those down below. But 3/4 is a common fraction that is equal to 75%. So if you got a 9 out of 13, you know you're pretty close to a 75%. Sometimes you might stretch the numbers a little further, especially if they're larger numbers. So in the next set, I look at 46 and 94, and those numbers don't go very well together, but I know that 46 isn't that far off from 50, and 94 isn't that far off from 100. So you might even stretch them that far and say this is about 50%, because you rounded each of those numbers to numbers that were more compatible. Again, this isn't giving you an exact answer. It's giving you an approximated answer. And by the way, this symbol here, we will be expected to use in our final answers anytime we estimate. So my final answer for these two would have actually been approximately 75%. And it's just like an equal sign that's with the squiggle. I'm sure you've seen it before. And then my final answer here would be approximately 50%. Okay, in addition to compatible numbers, we also want you to be very familiar with common percentages. So these are fractions that you should have memorized the common percentage. So 1/5, that's 0.2, so 20%. 1/4 is 0.25, 25%. 1/3 is approximately 0.3 repeating, so we'll say it's approximately 33.3%. 2/5 is double 1/5, so that's 40%. 1/2, of course, is 50%. 3/5 is 60%. 2/3, that's 0.6 repeating, or approximately 66.6. Actually, technically on that one, you'd round up to the 7. So we'll say 66.7%. 3/4, as we said earlier, is 75%. And 4/5 would be 80%. Okay. Our last strategy that we will use is the 10% rule. So if we're using the 10% rule, and this is the one that I would say people use probably most frequently, you can essentially 10% is very easy to find in your head because 10% of any number is just moving the decimal over one place. So 10% of 90 is 9. 10% of 900 is 90. 10% of 9 is 0.9. And I just randomly picked values there, all based on 9. But that's how we do the 10% rule. We just move the decimal over one place. So then if you can then find 10% of a number, it's very easy to manipulate to get to a smaller or larger multiple of 10. I really should have said larger, but you could do 5% by cutting it in half. So the example here given is 20% tip on a $50 bill. I could do that in my head. So here's how we would do it in our head. We know that 10% is just moving the decimal over 1. So 10% for 50, I just move the decimal over 1% or one place. So 10% would equal 5. So then if I want to find 20%, 20% is really just equal to 2 times 10%. So I would do 20% equals 2 times 5, and my answer would be $10. So my 20% tip on a $50 bill would be $10. Okay. If I wanted to approximate 7% tax on 50, now this isn't going to be exact. But what I could do is I know 10% very easily. 10% was equal to 5. Of course, we did that in the last example. So then I could think, okay, well, half of that would be 5%. So 5% would be equal half of 5, right? And that would equal 2.5. So that would tell me that 7% would be a little bit more than 2.5. So you might even find 2.5% by having 2.5 again, but you know you're going to be fairly close to $4. So 7% would be approximately $4 there. Again, this is just a technique. It's not an exact science, but it's using things that we know to approximate in our head without needing the use of a calculator to figure it out. So let's try a couple examples. So in this first set, we're going to practice using the 10% rule to estimate these. So let's start with A. So 10% of 48. So one thing that you need to remember too is you don't have to keep the numbers exactly as they are. You could make them a number that's slightly easier to work with. So I could actually instead say, well, 48 is awfully close to 50. So since these all are based on 48, 50 would be slightly easier to work with. So I could start by saying, okay, 10% of 48, and we'll change that to 50. So 10% of 50, and we did this one in the last one. We know to just move the decimal over one place. So our answer would be approximately 5. Now, the reason I'm putting the approximation there is because the original question was 10% of 48. So our answer is that 10% of 48 is approximately 5. Then 5% of 48 would be easy to find because what I would do is I would take my answer from the previous question and cut it in half. So I would say that since 5% is equal to half of 10%, I can just take half of the answer we got for 10%, which was 5, and say that our answer here is approximately 2.5. So 5% of 48 is approximately 2.5. Then here's how I can manipulate to get these a little bit larger. So this one is 62. So we'll say that in this case, let's say 62 is approximately 60. And so 10% of 60 would equal 6 because you just move the decimal once. 20% is 2 times 10%. So in my head, I'm writing 2 times, or I'm thinking 2 times 6. And then my answer here would be approximately 12, which means that 20% of 62 is approximately 12. Okay? Now on this next one, we can work to break down. So we'll again use 60 instead of 62. So if I think first 10%, I knew to be 6, right? 10% was 6. Based on what we did in the previous question, 20% was 12. And 5%, remember, would be half of 6, so that would be 3. So what I could actually do to find 35% is add all of these up, 10 plus 20 plus 5, and get an answer of 21. So my answer for 35% of 62 would be approximately 21. So you can use the previous percentages you found or break it down like that as one strategy. Of course, there are other methods to estimate, but this is one strategy that often works well. All right, next I'm going to look at some problems using compatible numbers and common percentages. So really, this is kind of up to you how you choose to do these. I want to kind of give you a mixture here. I'm going to probably use common fractions for all the ones where a percent is given. Common percentages where a percent is given. So let's go ahead and look at this. So 21% of 66. One way that you could think of this, other than the 10% rule, is you could realize that 21% is actually very close to 20%, and 66 is awful close to 65. Here's why that's helpful. We should kind of have memorized in our head that 20% is actually 1/5. And taking 1/5 of 65 is fairly easy because I just need to figure out how many times 5 goes into 65, which is 13. So I could say my approximate answer here is 13. This next one I like because I can actually change 36% and say that it's very close to 33% or a third. So really what we could do here is find a third of 120, which is just dividing 120 by 3. And so my answer would be approximately 40. I'm going to do something similar in letter C. 29% is fairly close to a third, and 86 is fairly close to 90. So I'm going to do a third of 90. See how we can do these rather quick in our head? And our answer would be approximately 30. On letter D, 44% of 130. Now this is a bit of a stretch, but that's fairly close to 50%. So that would be a half. And half of 130 is just 65. So we'd say approximately 65. Now, a quick comment. Even though we want you to do all of these in your head, we still want to see these little steps of work so that we can assess what estimation strategy you used when you were doing these. So on a quiz or a test, I still want to see one little quick step of work, 1 or 2 quick steps of work, just so I can see what you were doing. But anytime you see the word about, approximate, or estimate, you know you're going to be using one of these estimation strategies, especially if you see estimate. But here's another one, about. If you see about, that's one that you would want to use as well. So it says about what percent is 6 out of 25. So remember, we're thinking is over of here when we set this up. So 6 over 25. Those aren't very compatible. But this would be fairly easy to make compatible because I know that 6 is a factor of 24, and 24 is very close to 25. So I could make this 6 out of 24. Then the reason that's very easy to change to a percent is because it simplifies to 1/4. And I know that 1/4 is 25%. So when it says about what percent is 6 out of 25, I would say it's about 25%. Now make sure you include the percent symbol on this one because this was one of the questions that did not contain a percentage. All right, next. Example 3, we can see it says, you and your family go to TGI Fridays for dinner one night. Your bill is $65.20. If your family wants to tip 20%, what is the approximate amount of money they should give the waitress? So you don't need to give them an exact amount, but you want to be generous, hopefully, with your waiters or waitresses, your servers. And you also want to, just give them a rough amount that's pretty close to that percentage. So what I would probably do in this one is I'd take 65/20, and in my head, I know that that's awfully close to 65, or you could round up to be generous. Either one will work. And we actually did this one earlier. 20% of 65, I would use a common fraction here. You could use the 10% rule too, but I know that 20% is about a fifth. And I also know that of means multiply, and I know that 65 is divisible by 5. So since 5 goes into 65 exactly 13 times, I would leave a bill or a tip on my bill that is approximately $13. So a few quick reminders. Anytime you see the word about, estimate, or approximate, you can use an estimation strategy and should. When you see that on a quiz or a test, we will be looking for your ability to use one of these techniques. So please show us a quick step of work that you use for your estimation strategy, even though you should be remembering that this is something that you can do in your head. All right, thank you guys so much.